Before we go any further, pause for 1 second. If you've ever wondered whether Earth is truly special or just familiar, hit the like button right now, because what we're about to uncover isn't comfortable, and that's exactly why it matters. We grow up believing Earth is the blueprint for life. Blue oceans, green continents, stable seasons, a perfect distance from the sun. But perfection is a story we tell ourselves after the fact. In reality, Earth is full of compromises, near misses, and catastrophic mistakes. And the deeper scientists look into the data from the Kepler space telescope, the clearer it becomes. The universe may have done better elsewhere. Kepler wasn't designed to flatter humanity. It didn't search for meaning or destiny. It searched for patterns, and those patterns revealed something unsettling. Planets don't need to be exact Earth copies to support life. In fact, Earth-like conditions may not even be optimal. Our planet sits dangerously close to multiple failure modes. Our atmosphere is thin enough to leak into space over geological time. Our star is growing brighter at a pace that will eventually sterilize the surface. Our climate system can flip states with frightening speed. Earth works, but barely. Kepler revealed worlds that fix these flaws, slightly larger planets that hold thicker atmospheres, stars that evolve far more slowly than the Sun, orbits that remain stable for tens of billions of years. These aren't exotic anomalies. They appear again and again in Kepler's data. And that repetition is the key. When something repeats in nature, it's usually because it works better. Consider how fragile Earth's history has been. Mass extinctions reset life repeatedly. Asteroid impacts erased dominant species. Ice ages pushed ecosystems to the brink. Life survived, yes, but survival is not the same as thriving. On other worlds, life may never have faced those constant resets. While Earth was recovering from catastrophe after catastrophe, other planets may have enjoyed uninterrupted evolutionary progress. If that idea makes you uneasy, that's a good sign. It means you're starting to see Earth not as the universe's masterpiece, but as one version among many. If you're still with me, tap like now. It tells the algorithm this kind of deep space thinking belongs in your feed, because what comes next is where the illusion of Earth's uniqueness finally collapses. One of the biggest misconceptions about habitability is that it's a narrow target. One wrong variable and life collapses. Kepler shattered that assumption. It showed that life-friendly conditions exist across a wide spectrum of planetary environments. Many Kepler planets are what scientists call super-Earths, rocky worlds larger than our planet with stronger gravity and deeper atmospheres. That extra gravity matters. It helps retain heat, water vapor, and protective gases for billions of years longer than Earth can. On Earth, we worry about atmospheric loss and climate instability. On a super-habitable world, those threats are muted. Kepler also showed us that our Sun is not an ideal host star. It's relatively short-lived and increasingly volatile. Many Kepler planets orbit smaller, cooler stars that change far more slowly. These stars don't rush. They don't spike in brightness. They don't destabilize planetary climates every few 100 million years. From an evolutionary perspective, they are far better partners for life. Time is the most underrated ingredient for complexity. Evolution is not efficient. It experiments, it fails, it restarts. A planet that remains habitable for 20 or 30 billion years offers life far more opportunities to succeed than Earth ever will. And then there's stability. Earth's axial tilt, stabilized by the Moon, gives us seasons, but that setup is rare. Kepler data suggests some planets achieve long-term stability without large moons, simply through orbital dynamics. Stable tilt means predictable climates, fewer runaway ice ages, and ecosystems that don't need to constantly readapt to extreme swings. These are quiet advantages, but they compound over time. Earth's biosphere is resilient because it had to be. On many Kepler worlds, resilience may not be necessary. Life could flourish under conditions that never push it to the edge. If you're realizing that Earth's story might be more dramatic than ideal, hit like, because this realization is central to modern astrobiology. Kepler didn't just expand our list of planets, it expanded the definition of what a good world looks like. Now, let's confront the implication most people avoid. If better worlds are common, then life may be common too. And if life had more time and fewer interruptions elsewhere, intelligence may not be rare. Kepler data suggests that roughly half of all Sun-like stars host rocky planets in their habitable zones. But many of those stars are billions of years older than the Sun. That means potentially habitable planets existed long before Earth even formed. While Earth was still cooling, life elsewhere may have already begun. While complex life was just emerging here, ecosystems elsewhere may have already stabilized. This flips the timeline we're comfortable with. It suggests humanity is not early. It suggests we arrived late to a universe that had plenty of time to experiment without us. Earth's intelligence arose under pressure, under extinction events, climate swings, and cosmic impacts. That kind of intelligence is shaped by survival instincts. But intelligence that evolves under stability may look very different. It may not be aggressive. It may not be expansion-driven. It may not even be technological in the way we define it. Kepler's worlds force us to confront that possibility. They imply that the universe may favor patience over urgency, balance over chaos, continuity over disruption. Earth succeeded despite instability. Other worlds may succeed because of stability. And that distinction matters when we think about humanity's future. If Earth is a marginally habitable world nearing the end of its prime, then long-term survival means understanding which planetary systems endure and why. If this line of thinking feels uncomfortable, that's because it challenges our sense of cosmic importance. If you want more content that doesn't flatter humanity, but instead explains reality, leave a like now, because the final realization ties everything together. Kepler's legacy is not a list of planets. It's a shift in perspective. It tells us that Earth is not the universe's best attempt at life. It's simply one attempt that happened to include us. And that realization changes everything. It means the search for life is no longer about finding mirrors of Earth, but about finding worlds that fix Earth's weaknesses. Worlds with longer stability, gentler stars, thicker atmospheres, and deeper time horizons. These worlds are not destinations we can reach anytime soon, but they are benchmarks. They show us what works over cosmic timescales. They show us which conditions allow life to persist without constant crisis. And they quietly remind us that Earth's habitability is temporary. Our planet will not remain friendly forever. The sun will continue to brighten, oceans will evaporate, life will retreat or adapt until eventually Earth becomes another cautionary example in the cosmic archive. But Kepler tells us that this fate is not universal. Somewhere out there are worlds that will remain alive long after Earth falls silent. And that knowledge should not depress us. It should sharpen us. It should motivate us to preserve what we have while learning from what exists beyond us. If this video changed how you see Earth, make sure you're subscribed and hit like one last time so this perspective reaches others. Because the universe is not cruel and it's not kind. It's indifferent. Life emerges where conditions allow, and it fades where they don't. Kepler showed us that those conditions are more generous than we ever imagined. Earth is not the best world the universe could create. It's the one we inherited. And whether we learn from better worlds or disappear before we can depends entirely on what we do next.